All right, guys. Today we're going to talk about line of best fit. So in order to do that, we're going to start off with a little activity here. That was one of my favorite ones to do. So I'm a little bit sad that you guys aren't here because this was always a lot of fun. But if you look at the top of page 62 in your notebook, I've already filled out the first two columns here, but I'm going to explain what I did before I started this video. So the second column here that says estimated age, I tried to guess how old each of the people are that are over here on the left-hand side without Googling them first. So I took a guess, and then I Googled them to find out how old they actually are. So go ahead and take a second, pause this video, make sure you fill in those two columns, and then when you're ready, turn it back on again, and we'll start talking about whether or not we made, or I made in this case, an under or over estimate, and then we'll talk about what the ordered pair looks like. So if I'm looking at Beyonce, I guessed that she was 42 years old. Now, she's actually only 38. So now my job here is to decide, did I underestimate her age or overestimate her age? So I said she was 42, but she's younger than that. She's 38. So I was over by, let's see, 4, right? I was over by 4 years. Now, when you go to write the ordered pair, if you look, it says the actual age is your X value and the estimated age is your Y value. So the ordered pair would be 38, 42. That's what I'm going to write over here. And you'll see later why we're doing this. Okay? All right, take a look at Brad Pitt. I said he was 58. He's actually 56. So again, I was over by 2 years. And the ordered pair would be 56, 58. Okay, that's how old Brad Pitt is. All right, Justin Bieber, I said he was 27. I was actually pretty close. He's 26, but again, I was over by a year, and that ordered pair would be 26, 27. Okay, the lovely Betty White, I said she was 91, but she is in fact 98 years old. So for the first time, I was under, and I was under by a lot, by 7 years. Okay, so that ordered pair is 98, 91. Okay. LeBron James, I said he was 33, but he's actually 35. So again, I am under by 2 years this time, and that ordered pair is 35, 33. Okay. Jennifer Lawrence, you may know her from the Hunger Games. I said she was 32, but she is in fact 29. She's the same age as me. Would you look at that? All right, so once again, I was over this time by 3 years, and the ordered pair here would be 29, 32. All right, Lady Gaga, I said she was 34. She's in fact 33. So again, I was over by a year. That ordered pair is 33, 34. All right, Andrew Luck, for the first time, look at that. Spot on. So I was even here because I was not over and I was not under. And that ordered pair is 30, 30. All right, Mark Zuckerberg, the guy who invented Facebook, which I'm pretty sure y'all don't even use. I don't know. I think I'm old. He is, or I said he was 34, but he's actually 35, so I was under by a year. So that's 35, 34. Jimmy Kimmel, who has his own TV show, or late night talk show, I guess. I said he was 46, but he's actually 52. So once again, I am under, this time by 6 years, and the ordered pair is 52, 46. All right, last one, Kanye. I said he was 40, but he's actually 42, so I was under by 2 years, and his ordered pair is 42, 40. All right, so now what I want you to do is I want you to take time to plot each of these points, and I'm going to do it with you. So we are using the graph below here, and I'm just going to go straight down the list and plot each point, okay? So Beyonce was 38, 42. We're going to have to estimate for a lot of these, and that's okay. If you look, the x-axis is going up by 5s, 5, 10, 15, 20, 25, 30, etc., and so is the y, 5, 10, 15, 20, 25, 30, etc., okay? So first pair was 38, 42. So here's 35, 38 is pretty close to 40. I'm going to go about there, and I'm going to go up 42. So here is 40. 42 is slightly above that, so I'm just going to put it right here. Okay? The next one was 56, 58, so that's just a little bit more than 55. So 56, and then I'm going to go up to 58, which is just under 60, so I'm going to put it about there. The next one was 26, 27. So 26 is one more than 25. Here's 20, 25. 27 is almost 30. That's about there. All right. Then I have 91, which is here. And I got to go all the way up to 98. 98, which is almost 100. So that's way up here. All right. 35 is here. And 33. So here's 30. 33 is just above that. 29, 32. So 29, 32 is about there. 33, 34. That's almost 35. That's about there. And then the one that I got right was 30, 30, which is right there on the line. 30, 30. That'll be important later. 35, 34 is right about here. Okay. And then 52, 46. Was quite under on that one. Right about there. And the last one was 42, 40, which is about there. Okay. Now, if you look over to the right, there are 3 questions that we have to answer. The first of which is, what do you notice about the ordered pairs that were over estimates? So if they were over, so for example, 38, 42 is right here. 56, 58 is here. And then we had 26, 27, 26, 27. So all the points that I was over on are actually above the line. So they are above the line. So then where do you think all the estimates will be? So here we go. The first underestimate I had was Betty White. I think I might have plotted that one a little bit odd here. Yeah, it was supposed to be 98, 91. Why did no one stop me? Gosh, guys. So 98 is actually here. 91 is about here. So if you notice, it's below the line. Let's see, another one that I had wrong was 35, 33. That's about here. So if you notice, all the ones that are under, or that I was under on, are under the line. So they are below the line. And lastly, I only had one pair that I was even on. It was 30, 30. And where did that end up? On the line. Okay, so they are on the line. Okay, so that's important to know. Any of the points that we were over on were above the line. Any of the ones that were we were under on are below the line. And any of the perfect estimates, the ones that we got right on the button, are on the line. Okay, so that's important to know when it comes to line of best fit, because the line of best fit, while you do use all the stuff that we talked about when we did the linear chapter, the line of best fit is not going to have all the points in a straight line, because it is data, and we just talked about correlation versus causation, and this is graphically what it looks like. So if you remember from the last lesson, most of the examples that we had were all correlation, which meant that they were not in a straight line. They would be scattered about. So most of the graphs that we're going to deal with here are going to be scattered about. So if you turn to page 63, we're going to talk a little bit about the line of best fit in more detail than just the example. Okay, so up at the top, we have some information here. It says sometimes graphs will show a linear pattern of the data. If you can find a line or an equation to model the linear data, you can make predictions about that data. Now, in order for the line to fit, which is why it's called line of fit or line of best fit, it must do 2 things. The first is it must go in the same general direction of the data. And the second is there must be about the same number of points above the line as below the line. Those are the 2 rules that all of these line of fits have to follow, okay? If they don't, they are not a line of best fit, okay? So let's take a look at some examples down below and decide which of the lines that they gave us would be a better line of fit, okay? So on graph A, we have 2 options. We have line Q, which is running this way, and line P, which is running this way. All right, so our job is to decide, is line P or line Q a better line of best fit, and explain why we think so. So remember the 2 rules. They have to go in the same general direction of the points, and they must also have about the same number of points above and below the line, okay? So if you take a look, line P is going in the direction of the points, but line Q is not. So that automatically disqualifies it from being a good line of fit. So that means we're going to be taking a look at line P. So it's going in the direction of the points, and if you look, it has 1, 2, 3, 4, 5 points above, and 1, 2, 3, 4, 5 points below. Now, you're not always going to be able to get the exact same amount above and below the line, but if you're off by 1 or 2, that's okay. I want you to keep that in mind. But that proves here that line P is the better line of fit because it follows the direction of the points and has, we're going to say about the same number because that's what you're probably going to say most of the time. So has about the same number of points above and below the line. So anytime that we're asking you to explain your reasoning for this, this is the explanation we're going to be looking for. If you are saying that a line is a good line of fit, you're going to say exactly what we said here. If it is not a good line of fit, you need to say one of two things. You need to say either the line does not go in the direction of the points, like line Q does here, or you need to say that there are not an even distribution of the points, which what that means is they're not about the same number of points above and below the line. And you can say that by either saying exactly what I just said, or you can say that all the points are above the line or below the line, or there are too many points above or below the line. Okay, so let's take a look at graph C. All right, so graph C wants to know, is line S or line T a better line of fit, and explain your reasoning. Okay, so both lines seem to be going in about the direction of the points, even though they're going in different directions. So this one is going this way, this one is slightly more negative this way. So what we're going to have to do is we're going to have to take a look at the number of points above and below each line. So let's focus on line S first. That's this line right here. Okay. So let's see. We have 1, 2, 3, 4, 5, 6, 7 above, and 1, 2, 3, 4, 5, 6, 7 below. So that looks good. Now let's focus on line T. Line T has 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9 rather above, and 1, 2, 3, 4, 5, 6, 7, 8 below. Now, if you remember, I told you that if you're off by 1 or 2, that's totally okay. So technically, either line here is a better fit because they follow both of the rules, but technically line S is the better one. But for the sake of argument here, I'm going to say either line works because they both go in the direction of the points. And the points are evenly distributed. Okay. All right, so regardless of what line you chose, that would be fine. But like I said, line S technically has an equal amount on both sides, so it would be the better one. All right, now the last one down at the bottom, it says, why is there no line of best fit shown? Now, in order to have a line of best fit, you must be able to tell whether or not the graph is going in a positive direction or a negative direction. If you look here, the points are just kind of all over the place. They're not going in any direction whatsoever. So that means that there is no linear pattern here. Okay, so what that means is there is no general direction of the points. They are very scattered. Now, a graph like this would definitely represent something that has no correlation whatsoever. So you cannot make a line of best fit for something that looks like this. Okay? That's it for the notes for today. Your job now is to complete the practice on page 64 to 66. And again, as always, if you have questions, feel free to reach out to either myself or Mrs. Ripley. We'll be glad to help you. All right? Have a great day, guys.